Hello viewers, welcome to my channel Online Biology Tutorials. In today's live, we will be reading the chapter number 4, Structure of the Atom from grade 9 NCERT. I hope the screen is visible to everybody. So let's start with chapter 4, the structure of the atom. Whenever you'll be watching this video, please share it with your friends so that they can also hear the audio and take the benefit of revising the chapter in a great way. Let's start. In chapter 3, we have learned that atoms and molecules are the fundamental building blocks of matter. The existence of different kinds of matter is due to different atoms constituting them. Now the question arises: 1. What makes the atom of an element different from the atom of another element? And 2. Are atoms really indivisible as proposed by Dalton? Or are they smaller constituents inside the atom? We shall find out the answers to these questions in this chapter. We will learn about subatomic particles and the various models that have been proposed to explain how these particles are arranged within the atom. Please hit the like button if you are really liking this video. Next paragraph. A major challenge before the scientists at the end of the 19th century was to reveal the structure of the atom as well as to explain its important properties. The elucidation of the structure of atoms is based on a series of experiments. One of the first indications that atoms are not indivisible comes from the study static electricity and the condition under which electricity is conducted by different substances. Let's move to another topic. It is 4.1, charged particles in matter. For understanding the nature of charged particles in matter, let us carry out the following activities. Activity 4.1. A. Comb dry hair. Does the comb then attract small pieces of paper? B. Rub a glass rod with a silk cloth and bring the rod near an inflated balloon. Observe what happens. I hope the screen is visible to everybody. From these activities, can we conclude that on rubbing two objects together, they become electrically charged? Where does this charge come from? This question can be answered by knowing that an atom is it is divisible and consists of charged particles. Many scientists contributed in revealing the presence of charged particles in an atom. Thank you, Ayush. Ayush, just visit my channel. I have a playlist for class 11th also. Class 11th bio has been recorded in case you are from the science stream. Just write your stream in the chat so that I can come to know. So I was here in the third paragraph. It was known by 1900 that the atom was indivisible particle but contained at least one subatomic particle, the electron identified by J.J. Thomson. Even before the electron was identified, E. Goldstein in 1886 discovered the presence of new radiations in a gas discharge and called them canal rays. These rays were positively charged radiations which ultimately led to the discovery of another subatomic particle. This subatomic particle had a charge equal in magnitude but opposite in sign, so that of the electron. Its mass was approximately 2000 times as that of the electron. It was given the name of a proton. In general, an electron is represented as E minus and a proton as P plus. The mass of a proton is taken as 1 unit and its charge as plus 1. The mass of an electron is considered to be negligible and its charge is minus 1. Now, let's come on to the next paragraph. It seemed that an atom was composed of protons and electrons, mutually balancing their charges. It also appeared that the protons were in the interior of the atom, for whereas electrons could easily be removed off but not protons. Now, the big question was what sort of structure did these particles of atom form? We will find the answer to these question below. Let's flip to the another page. And here we have in-text questions. I hope the screen is visible to everybody. So the question number 1 at the top is what are canal rays? Question number 2, if an atom contains one electron and one proton, will it carry any charge or not? Next topic 4.2, the structure of an atom. We have learned Dalton's atomic theory in chapter 3, which suggested that the atom was indivisible and indestructible. But the discovery of two fundamental particles, electrons and protons, inside the atom led to the failure of this aspect of Dalton's atomic theory. It was then considered necessary to know how electrons and protons are arranged within an atom. For explaining this, many scientists proposed various atomic models. J.J. Thomson was the first one to propose a model for the structure of an atom. Let's move on to the next topic, and here it is 4.2.1 Thomson's model of an atom. Thomson proposed the model of an atom to be similar to that of a Christmas pudding. The electrons in a sphere of positive charge were like currants, dry fruits in a spherical Christmas pudding. We can also think of a watermelon. The positive charge in the atom is spread all over like the red edible part of the watermelon, while the electrons are studded in the positively charged sphere like the seeds in the watermelon. Figure 4.1, it is showing you Thomson's model of an atom. Let's come to this side of this page. So it is J.J. Thomson, 1856 to 1940, a British physicist, was born in Chatham Hill, a suburb of Manchester, on 18 December 1856. He was awarded the Nobel Prize in Physics in 1906 for his work on the discovery of electrons. He directed the Cavendish Laboratory at Cambridge for 35 years, and 7 of his research assistants subsequently won Nobel Prizes. Next paragraph. Thomson proposed that 1. An atom consists of a positively charged sphere and the electrons are embedded in it. Second, the negative and positive charges are equal in magnitude, so the atom as a whole is electrically neutral. Although Thomson's model explained that atoms are electrically neutral, the results of the experiments carried out by other scientists could not be explained by this model, as we will see below. 4.2.2 Rutherford model of an atom. I hope the screen is visible to everybody. Do hit the like button in case you are able to see. Let's proceed. Ernest Rutherford was interested in knowing how the electrons are arranged within an atom. Rutherford designed an experiment for this. In this experiment, fast moving alpha particles were made to fall on a thin gold foil. He selected a gold foil because he wanted as thin a layer as possible. This gold foil was about 1000 atoms thick. Alpha particles are doubly charged helium ions. Since they have a mass of 4u, the fast moving alpha particles have a considerable amount of energy. Next point. It was expected that alpha particles would be deflected by the subatomic particles in the gold atoms. Since the alpha particles were much heavier than the protons, he did not expect to see large deflections. Let's move on to next page, this side. I hope it is visible to everybody. Figure 4.2, scattering of alpha particles by a gold foil. But the alpha particle scattering experiment gave totally unexpected results. The following observations were made. 1. Most of the fast moving alpha particles passed straight through the gold foil. 2. Some of the alpha particles were deflected by the foil by small angles. 3. Surprisingly, 1 out of every 12,000 particles appeared to rebound. In the words of Rutherford, this result was almost as incredible as if you fire a 15-inch shell at a piece of tissue paper and it comes back and hits you. Now let's read this yellow block. E. Rutherford, 1871 to 1937, was born at Spring Grove on 30th August 1871. He was known as the father of nuclear physics. He is famous for his work on radioactivity and the discovery of the nucleus of an atom with the gold foil experiment. He got the Nobel Prize in Chemistry in 1908. Now let's see the last paragraph. Let us think of an activity in an open field to understand the implications of this experiment. Let a child stand in front of a wall with his eyes closed. Let him throw stones at the wall from a distance. Let's come to this side now. He will hear a sound when each stone strikes the wall. If he repeats this 10 times, he will hear the sound 10 times. But if a blindfolded child were to throw stones at a barbed wire fence, most of the stones would not hit the fencing and no sound would be heard. This is because there are lots of gaps in the fence which allow the stone to pass through them. Following a similar reasoning, Rutherford concluded from the alpha particle scattering experiment that most of the space inside the atom is empty because most of the alpha particle passed through the gold foil without getting deflected. Very few particles were deflected from their path, indicating that the positive charge of the atom occupies very little space. A very small fraction of alpha particles were deflected by 180 degree, indicating that all the positive charge and the mass of the gold atom was concentrated in a very small volume within the atom. From the data, he also concluded that the radius of the nucleus is about 10 to the power 5 times less than the radius of the atom. On the basis of his experiment, Rutherford put forward the nuclear model of an atom which had the following features. 1. There is a positively charged center in an atom called nucleus. Nearly all the mass of an atom resides in the nucleus. The electrons revolve around the nucleus in circular paths. The size of the nucleus is very small as compared to the size of the atom. Now let's see this last paragraph. I hope the screen is visible. Drawbacks of Rutherford model of the atom. The revolution of the electron in a circular orbit is not expected to be stable. Any particle in a circular orbit would undergo acceleration. During acceleration, large charged particles would radiate energy, thus, the revolving electron would lose energy and finally fall into the nucleus. If this was so, the atom should be highly unstable and hence matter would not exist in the form that we know. We know that atoms are quite stable. So, we are done with this page. Let's flip to the next. And here is the next topic. 4.2.3 Bohr's model of atom. In order to overcome the objections raised against Rutherford's model of the atom, Niels Bohr put forward the following postulate about the model of an atom. Point number one, only certain spatial orbits known as discrete orbits of electrons are allowed inside the atom. While revolving in discrete orbits, the electrons do not radiate energy. Neil Bohr, 1885 to 1962, was born in Copenhagen on 7th October 1885. He was appointed professor of physics at Copenhagen University in 1916. He got the Nobel Prize for his work on the structure of atom in 1922. Among Professor Bohr's numerous writings, three appearing as books are: 1. The Theory of Spectra and Atomic Constitution, 2nd. Atomic Theory, and 3. The Description of Nature. Now, these orbits or shells are called energy levels. Energy levels in an atom are shown in figure 4.3. Figure 4.3 is showing you a few energy levels in an atom. The orbits or shells are represented by the letters K, L, M, N, and so on, or the numbers n is equals to 1, 2, 3, 4, etc. Let's see these in-text questions on page number 41 of your book. Question number 1. On the basis of Thomson's model of an atom, explain how the atom is neutral as a whole. On the basis of Rutherford's model of an atom, which subatomic particle is present in the nucleus of an atom? 3. Draw a sketch of Bohr's model of an atom with three shells. 4. What do you think would be the observation if the alpha particle scattering experiment is carried out using a foil of a metal other than gold? Now let's come on to this one, 4.2.4 neutrons. I hope the screen is visible to everybody. To hit the like button and do not forget to share this live with your friends so that they can also hear this audio and revise the chapter in a great way. 4.2.4 Neutrons. In 1932, J. Chadwick discovered another subatomic particle which had no charge and a mass nearly equal to that of a proton. It was eventually named as neutron. Neutrons are present in the nucleus of all atoms except hydrogen. In general, a neutron is represented as n. The mass of an atom is therefore given by the sum of the masses of protons and neutrons present in the nucleus. Let's see the in-text questions now. Name the three subatomic particles of an atom. Question number 2. Helium atom has an atomic mass of 4U and 2 protons in its nucleus. How many neutrons does it have? Next one, 4.3. How are electrons distributed in different orbits or shells? The distribution of electrons into different orbits of an atom was suggested by Bohr and Bury. The following rules are followed for writing the number of electrons in different energy levels or shells. Point number 1, the maximum number of electrons present in a shell is given by the next page. I hope the screen is visible. Formula 2n square, where n is the orbit number of the energy level index 1, 2, 3, and so on. Hence, the maximum number of electrons in different shells are as follows. First orbit or K shell will be 2 into 1 to the power 2, that becomes 2. Second orbit or L shell will be 2 into 2 to the power 2, that becomes 8. Third orbit or M shell will be 2 into 3 to the power 2 is equals to 18. Fourth orbit or N shell will be 2 into 4 to the power 2, that will become 32, and so on. The maximum number of electrons that can be accommodated in the outermost orbit is 8. 3. Electrons are not accommodated in a given shell unless the inner shells are filled. That is, the shells are filled in a stepwise manner. Atomic structure of the first 18 elements are shown symmetrically in figure 4.4. Now, activity 4.2. Make a static atomic model displaying the electronic configuration of the first 18 elements. The composition of atoms of the first 18 elements is given in table 4.1. In text questions, question number 1, write the distribution of electrons in carbon and sodium atoms. Question number 2, if K and L shells of an atom are full, then what would be the total number of electrons in the atom? 4.4 valency. We have learned how the electrons in an atom are arranged in different shells or orbits. The electrons present in the outermost shell of an atom are known as valence electrons. From the Bohr-Bury scheme, we also know that the outermost shell of an atom can accommodate a maximum of 8 electrons. It was observed that the atoms of an element completely filled with 8 electrons in the outermost shell show little chemical activity. In other words, their combining capacity or valency is 0. For these inert elements, the So I have come to the next page and I am on this paragraph now. Helium atom has 2 electrons in its outermost shell and all other elements have atoms with 8 electrons in the outermost shell. The combining capacity of the atoms of element, that is, their tendency to react and form molecules with atoms of the same or different elements, was thus explained as an attempt to attain a fully filled atom outermost shell. An outermost shell. Hi, Mastermind, you have just joined. An outermost shell, which had 8 electrons, was said to possess an octet. Atoms would thus react so as to achieve an octet in the outermost shell. This was done by sharing, gaining, or losing electrons. The number of electrons gained, lost, or shared so as to make the octet of electrons in the outermost shell. Give us directly the combining capacity of the element, that is, the valency discussed in the previous chapter. For example, hydrogen, lithium, sodium atoms contain one electron each in their outermost shell. Therefore, each one of them can lose one electron. So, they are said to have valency of 1. Can you tell what is the valency of magnesium and aluminium? It is 2 and 3 respectively, because magnesium has 2 electrons in its outermost shell and aluminium has 3 electrons in its outermost shell. Do hit the like button in case you are liking the audio. If the number of electrons in the outermost shell of an atom is close to its full capacity, then valency is determined in a different way. For example, the fluorine atom has 7 electrons in its outermost shell and its valency could be 7, but it is easier for. Before I proceed to the next page, table 4.1 is very important for you. It is giving you the composition of atoms of the first 18 elements with electron distribution in various shells. So the elements that are being given to you are hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Symbol is given, atomic number is given, number of protons, number of neutrons, number of electrons, distribution of electrons in K, L, M, N, N, and then the valency. This is going to be the very important table that you should understand each part. Now I am coming to the next page and I hope the screen is visible. Let's go ahead. Fluorine to gain one electron instead of losing 7 electrons. Hence, its valency is determined by subtracting 7 electrons from the octet, and this gives you a valency of 1 for fluorine. Valency can be calculated in a similar way for oxygen. What is the valency of oxygen that you get from this calculation? Therefore, an atom of each element has a definite combining capacity called its valency. Valency of the first 18 elements is given in the last column of table 4.1. In text question number 1, how will you find the valency of chlorine, sulfur and magnesium? Let's move on to the next topic, that is 4.5, atomic number and mass number. 4.5.1, atomic number. We know that protons are present in the nucleus of an atom. It is the number of protons of an atom which determines its atomic number. It is denoted by Z. All atoms of an element have the same atomic number Z. In fact, elements are defined by the number of protons they possess. For hydrogen, Z is equals to 1 because in hydrogen atom only one proton is present in the nucleus. Similarly, for carbon, Z is 6. Therefore, the atomic number is defined as the total number of protons present in the nucleus of an atom. I hope the screen is visible to everyone. Do hit the like button and keep sharing with your friends. Next topic 4.5.2, mass number. After studying the properties of the subatomic particles of an atom, we can conclude that mass of an atom is practically due to protons and neutrons alone. These are present in the nucleus of an atom. Hence, protons and neutrons are also called nucleons. Therefore, the mass of an atom resides in its nucleus. For example, mass of carbon is 12U because it has 6 protons and 6 neutrons. So I am here at the topmost paragraph. 6U plus 6U is equals to 12U. Similarly, the mass of aluminium is 27U because it has 13 protons and 14 neutrons. The mass number is defined as the sum total of total number of protons and neutrons present in the nucleus of an atom. It is denoted by letter A. In the notation of an atom, the atomic number, mass number, and symbol of the element are to be written as. Symbol of the element, suppose it is X. Mass number A is written as superscript. Atomic number is written with the letter Z or Z and it is written as a subscript. So if you want to denote it For nitrogen, suppose, then it will be written as N14 as superscript, 7 as subscript. In text questions now. If number of electrons in an atom is 8 and the number of protons is also 8, then 1, what is the atomic number of the atom? And 2, what is the charge on the atom? 2. With the help of table 4.1, find out the mass number of oxygen and sulfur atoms. Let's come on to this part, which is 4.6 isotopes. In nature, a number of atoms of some elements have been identified which have the same atomic number but different mass numbers. For example, take the case of hydrogen atom. It has three atomic species, namely protium H11, deuterium H21 or D, or tritium H31 or T. The atomic number of each one is 1, but the mass number is 1, 2, and 3 respectively. Other such examples are carbon 12, 6 and carbon 14, 6. Third one, the second one, chlorine 35, 17 and chlorine 37, 17, etc. On the basis of these examples, isotopes are defined as the atoms different mass numbers. Therefore, we can say that these three isotopes of hydrogen atom, namely protium, deuterium, and tritium. Coming on to the next page, which is the last page. I hope the screen is visible to everybody. Keep sharing this live so that others can also hear it. This is the live of structure of 9 NCERT science. Many elements consist of a mixture of isotopes. Each isotope of an element is a pure substance. The chemical properties of isotopes are similar, but their physical properties are different. Chlorine occurs in nature in two isotopic forms with masses 35U and 37U in the ratio 3:1. Obviously, the question arises, what should we take as the mass of chlorine atom? Let us find out. The average atomic mass of chlorine atom on the basis of above data will be 35 into 75 divided by 100 plus 37 into 25 divided by 100. So 105 upon 4 plus 37 divided by 4 in brackets will give you 142 divided by 4 is equal to 35.5 U. The mass of an atom of any natural element is taken as the average mass of all the naturally occurring atoms of that element. If an element has no isotopes, then the mass of its atom would be the same as the sum of the protons and neutrons in it. But if an element occurs in isotopic forms, then we have to know the percentage of each isotopic form and then the average mass is calculated. This does not mean that any one atom of chlorine has a fractional mass of 35.5 U. It means that if you take a certain amount of chlorine, it will contain both isotopes of chlorine and the average mass is 35.5 U. Now, to the right side of this page, number 45 of your book. Since the chemical properties of all the isotopes of an element are the same, normally we are not concerned about taking a mixture, but some isotopes have special properties which find them useful in various fields. Some of them are 1. An isotope of uranium is used as a fuel in nuclear reactors. 2. An isotope of cobalt is used in the treatment of cancer. 3. An isotope of iodine is used in the treatment of goiter. Last topic 4.6.1 isobars. Let us consider two elements, calcium atomic number 20 and argon atomic number 18. The number of protons in these atoms is different, but the mass number of both these elements is 40. That is, the total number of nucleons is the same in the atoms of this pair of elements. Atoms of different elements with different atomic numbers which have the same mass number are known as isobars. In text question number 1, for the symbol HDT, tabulate three subatomic particles found in each of them. Question number 2, write the electronic configuration of any one pair of isotopes and isobars. With this, we come to an end of the reading. Only the summary part is left. Let's go and quickly finish it. So, what have you learned from the summary of structure of the atom? So, first point, credit for the discovery of electron and proton goes to J.J. Thomson and E. Goldstein, respectively. J.J. Thomson proposed that electrons are embedded in a positive sphere. Next point, Rutherford alpha particle scattering experiment led to the discovery of the atomic nucleus. I hope the screen is visible to everybody. Rutherford's model of the atom proposed that a very tiny nucleus is present inside the atom and electrons revolve around this nucleus. The stability of the atom could not be explained by this model. Excuse me. Niels Bohr model of the atom was more successful. He proposed that electrons are distributed in different shells with discrete energy around the nucleus. If the atomic shells are complete, then the atom will be stable and less reactive. Let's move on to next part. So we have read fourth point. Let's come on to fifth one now. Niels Bohr's model of the atom was more successful. He proposed that electrons are distributed in different shells with discrete energy around the nucleus. If the atomic shells are complete, then the atom will be stable and less reactive. J. Chadwick discovered the presence of neutrons in the nucleus of an atom. So, the three subatomic particles of an atom are 1. Electrons, then protons, third neutrons. Electrons are negatively charged, protons are positively charged, and neutrons have no charges. The mass of an electron is about 1 by 2000 times the mass of an hydrogen atom. The mass of a proton and a neutron is taken as 1 unit each. Shells of an atom are designated as K, L, M, N, and so on. Valency is the combining capacity of an atom. The atomic number of an element is the same as the number of protons in the nucleus of its atom. The mass number of an atom is equal to the number of nucleons in its nucleus. Isotopes are atoms of the same element which have different mass numbers. Isobars are atoms having the same mass number but different atomic numbers. Elements are defined by the number of protons they possess. So here we are done with the reading of structure of the atom for class 9 science NCERT. Whenever you will hear this audio, please share it with your friends for the maximum reach. Do consider subscribing, and if you have liked the audio, do hit the like button. Stay connected. See you in next video.